Chapter students to the homework help video, page 571. Let's go ahead and get started with today's problems, okay? First of all, numbers 1 through 4, they want us to find the area of the shaded region, okay? The area of the shaded region. Now, number 1 is pretty simple. The entire circle is shaded in. So in order to find the area of a circle, we use the formula pi times r squared, okay? Obviously, pi is 3.14 and the radius is 7. So don't forget, you first square the 7 before you multiply it by 3.14. Okay, please don't forget to do that. So if you square the 7, you'll get 49. So 3.14 times 49 would give you 153.86. Now our answers are going to continually be off a little bit from the book because they're using the actual pi button on their calculator, okay? But that's okay. That's not a big deal. It'll be very, very close every time, okay? Alright, moving on to number 2. Now, you can look in your book and see this is the shaded area right here. They want us to find the area of that shaded region, okay? So, here's what we're going to do. First of all, we're going to find the area of the entire circle. So we're going to take 3.14 times the radius squared, okay? So if we do that with our calculators, we're going to get 78.5. So the area of the circle equals 78.5. Okay? Now, square centimeters if you want to get picky. Now, let's find what percentage or what fraction this sector is of the entire circle. So 105 over 360. Alright? If you reduce that, you're going to get 7/24. So this entire sector is 7/24 of the entire circle. So we take our entire area, 78.5, of means times, so times the fraction, 7/24. So 7/24 times 78.5 is going to give you 22.89 square centimeters. Now their answer will be a little different, but nonetheless, be very close, okay? Alright, moving on to number 3. The shaded area, although you can't see it on here very well, but in your book you know, it's this segment right here. Remember, whenever a chord and its intercepted arc form a region on a circle, we call that a segment of a circle, okay? So that's the part we're trying to find the area of right there, okay? So here's my suggestion. Let's find this whole area right here. That's called a sector. Let's find this whole sector, okay? And then subtract out the triangle right here. And if you subtract out the triangle, what you're left over with is this part right here, alright? So let's first find the area of the entire sector. I'm going to draw it over here so we have a little bit more room to work with, okay? So here's the sector right here. Okay, that thing is the exact same thing as this here, supposedly, okay? This is 60 degrees, and this is 4 inches. Now, okay, let's find the area of this entire sector. So first of all, I'm going to find the area of this entire circle, first of all. The entire circle. So 3.14 times 4 squared. So 3.14 times 16 is 50.24. So the area of the entire circle is 50.24. Alright, now, what fraction of the circle is 60 degrees? Well, it's 1/6. If you take 60 and put it over 360, cross off your zeros, 6 goes into 6 ones, 36 ones, so 1/6. So this whole entire sector, everything, this whole sector is 1/6 of the entire circle. Got it? So I'm going to take the entire area times 1/6. So 50.14 times 1/6. It's going to give me 8.373333. So I'm going to come over here and put sector equals 8.37. Okay? Now, think about it, guys. If the entire area of this sector, this entire area is 8.37, if I can just very simply subtract out the this triangle right here, if I triangle. Look what's left. The only thing left is this black part right over here to the right here, and that's exactly what I'm trying to find, is that area right there. Okay, so hopefully this will work. Okay, so let's find the area of the triangle. So here's the triangle right here. I'm on the wrong color still. There we go. Here's the triangle right here. So I'm going to draw that down here so we can see it better. Okay, there's the triangle. This is 60. Now, if this is 4, what is this right here then? 4. So if this is 4, this has to be 4. Well, hold on a second, students. We learned a long time ago that if two sides of a triangle are congruent, their opposite angles are congruent. So this angle has to be congruent to this angle. Well, hold it. If this is 60, and these two have to be congruent, we have a 60-60 triangle. Can I go ahead and tell you something right now? From now on, during the rest of this homework lesson, and during the rest of your mathematical life, anytime you have a sector of a circle in which the central angle is 60, it has to be a central angle coming from the center of the circle. It'll always be an equilateral, equiangular, regular triangle. Always, always. Got it? Okay, so we have a 40, we have a 60-60, 60 triangle, okay? And we know this side here is 4, this side's 4. We know this side has to be 4 also then, because it's equilateral, equiangular. So, watch this, in order to find the area of this triangle, what's my formula? 1/2 times the base times the height, correct? Sure it is. So, there we go. Okay, so, if I cut this 60 in half, this will be 30, this will be 60. Does everybody see what I have, guys? I have a 30-60 90 triangle. Come on, students, you gotta see that, okay? This whole big angle up here was 60. I dropped this line straight down. Why? Because I have to know the height. If I don't know the height, then I can't find the area. So once I drop this down, so I cut that 30 in half, I have a 30-60-90 triangle. So I can find this height very quickly. Watch. Here's the hypotenuse, right? Here's my right triangle right here. There's my right triangle. See it? This is my hypotenuse for. We learned a long time ago that in a 30-60-90 triangle, cut the hypotenuse in half, and the shorter leg is 2. Then you take the shorter leg and multiply it by the square root of 3, and you have the longer leg. So booyah, just like that, finished, done. The entire height of that triangle is 2 square root of 3, just like that. Okay? Now the base is this whole length down here, and that's 4. So my base is 4. So just like that, I can find the area of the triangle. So now, students, with my handy dandy calculator, I'm going to take 0.5 times 4 times 2 square root of 3, and the area of the triangle is, and I think I messed up here, hold on one second, students, is going to be 6.92. So the area of the triangle is 6.92. So remember, the whole sector was this, the triangle's this, subtract those two numbers, and we should have an answer that's hopefully very close to the correct answer. I'm getting 1.44 when I subtract these two numbers, and the answer is 1.45, okay? So we're basically right on the money. Alright, moving on to number 4. Alright, now they want us to find the area of this outer ring right here. Okay, so let me give you a suggestion. If I find the area of this entire circle, alright, and then find the area of that inner white circle, and then subtract it out, look what I'm left over with. If I subtract out this inner white circle, find the area of that inner white circle, and subtract it out, I'm left with the ring. So the goal is to find the entire circle, the area of the entire circle, and then find the area of that little white circle, and then subtract the two, okay? So the area of the big circle, I'm going to put area of big circle would be, well, the radius of the big circle goes from here all the way out 30, so it'd be 3.14 times 30 squared. Let's see what that would be. 2,826. Okay, now let's find the area of the little circle. Well, the radius of the little circle is 20, so 3.14 times right circle is this. Subtract the 2, and you're going to get 1,570. 1,570. Alright? Okay. Moving on to number 5. Now, 5 through 8. If you read the directions carefully, they want us to find the percentage of each shaded area. Well, this is going to be pretty easy. First of all, they want to know what percentage the yellow circle is of the entire circle. Okay, no problem, guys. Look, find the area of the entire big circle. In fact, you need to find that right away, don't you? Come on, think about it. The entire big circle is 100%. So let's find the area of the entire big circle right off the bat. We're going to use that a lot, okay? So the area of the big circle is, what's the radius? Let's see. Well, from here to here is 3. And from here to here is 2 more, because we know that right here. So the whole radius of the whole circle is going to be 5, okay? So the radius of the whole circle will be 5. So I have 3.14 times 5 squared. Let me get out my calculator again here. Let's see what we get. 78.5. So don't forget that we're going to write that up here in green. We're going to use that a lot. So the area of the entire big circle is 78.5. Now, question number 1, they want us to find the area. What percentage is the yellow circle? Okay, let's find the area of the yellow circle. The radius is 3. Okay, so the area of the little circle would be 3.14 times 3 squared, which gives you 28.26. So if the area of the little yellow circle is 28.26, you put that over the entire circle, which is 78.5. Just use your calculator, no big deal. Hit divide, and you should get 0.36. Now, students, 0.36, of course, move the decimal 2 places, is 36%. So 5 would be letter C, 36%. Not too bad. Now, let's take a look at number 6. They want to know what percentage the sector SR is. Now here's sector SR. Let's draw this out so we can see it, okay? Here's sector, or it says, yeah, sector SR. Right here, there it is. Got it? They want to know what percentage that is of the entire circle. We already know the entire circle has this area right here. All we have to do is find the area of this sector right here. Well, guys, if the arc's 120 degrees, then the central angle is 120 degrees. So what fraction am I dealing with? Well, I'm dealing with 1/3 if you reduce that. So this sector is 1/3 of the entire circle. So I take let's stop right there. I'm not sure exactly what I'm thinking, but I don't need to find the area at all. To be honest with you, not a bit. I'm not sure why I'm doing that. I just told you this entire sector is what of the entire circle? 1/3. And 1/3 equals what percent? 33 1/3 percent. So there we go. How do I get that? Take 1 divided by 3, and you get 0.33 repeating. Alright? So, I mean, think about it, guys. If the entire circle is 100%, and this is 1/3 of that, which it is, then the percentage has to be 33 1/3 percent, which would be letter A. Alright, moving on to C. Now they want us to find the percentage of the blue ring. Now, guys, I want you to really stop and think this through. We don't have to do anything. What is the percentage of the entire circle? 100%. What is the percentage of the yellow circle? We already found that. 36%. So if you take 100%, which is the entire circle, minus 36%, you're left with 64%. So the blue ring has to be 64% of the entire circle. Do you see how I did that? The whole circle is 100%, okay? And this inner yellow circle right here is 36%. So take the whole percentage, 100%, minus 36%, and you get 64%. Alright, so there we go, and that would be letter B, 36%, or wow, 64%. Okay, now, the segment bounded by RT and RT. This little bit right here. Okay, find the area of that whole sector, everything. And then find the area of that triangle right here and subtract out that triangle. Okay, like that. And then once you subtract out the triangle, you're left with the area of that little sector right here. That's the only way I know to do it. So I'll take a little bit of time. Let's go ahead and get started, okay? First of all, let's find the area of this entire sector. Now it looks like this sector I'm trying to find the area of right here has a central angle of 90. So what fraction would that be? 90 over what? 3/6. That reduces to 1/4. So the area of the entire sector is, I'm going to take my entire area of the whole circle, 78.5, times 1/4, because I'm trying to find just 1/4 of the entire circle, and I'm going to get this, 19.625. So there's the area of the sector. I'm going to write it down here. The area of the sector is 19.625. Now, next I have to find the area of this triangle right here, right there, and then subtract that out, and I'll have the area of this little sliver right here, okay? So let's find the area of this black triangle right here. Now students, the triangle is not going to be that difficult. Here it is right here. I kind of flipped it. Here's the right angle right here. So I'll put a right angle right here. Okay, now we know this length here is 5, and this length here is 5. So this is 5, and this is 5 right here, and this is 90. Well guys, look, this is so simple. Just take the triangle and turn it. Please look at this, students. Whenever you have a 90-degree angle for your central angle, there's your triangle. Look at that. Here's your base, 5. Here's your height, 5, because that's a 90-degree angle right there. So 1/2 times base times height, 1/2 times 5 times 5 would be 12.5. So just like that, you found the area of this entire triangle. Listen, let's review. Anytime your central angle right here is 60, then your triangle will be a 60, 60, 60 triangle, always equilateral. Anytime your triangle here is, anytime your angle right here is 90, you can find the area by taking the radius times 1/2. In other words, base times height divided by 2. Please don't forget that, makes it a lot easier. So the area of the triangle is 12.5. So the triangle is 12.5. So subtract these two. The entire sector is this. The triangle's this. So we end up with 7.625. So the area of this region, this segment right here, is 7.625. Now we want to find what percentage that is of the entire circle. So put that over your area of the whole circle, and you'll get your percentage, 7.625 out of 78.5, and I'm getting 0.0971. Move the decimal 2 places. 9.7. They're getting 9.1. So I mean, again, close enough, guys. We're always going to be off a little bit because of what we use for the radius and stuff like that. But there it is. Okay, so pretty simple. All right, moving on to numbers 9 through 16. The directions say to find the area of the shaded region. Okay, now this will really be pretty simple, guys. They want us to find this area right here. So first of all, I wonder what fraction that is of the entire circle. 295 over 360. Let's see what fraction that is of the entire circle. Looks like 59. If you reduce it, you get 59 over 72. And by the way, you don't have to reduce it. If you want to use that fraction there, you'll get the right answer. Now the area of the entire circle is 3.14 times the radius squared. So 3.14 times 36 would be 113. 113.04. Okay, that's the whole circle. Multiply that by your fraction, 59 over 72, and we should get. And by the way, if you used 295 over 360, you'll get the same answer. It's fine. You're going to get 92.63. And I'm looking at the answers right here. They have 92.68, so we are totally right on the money. Okay, there we go. Moving on to number 10. students, on number 10, we're finding the area of the entire circle. That should be pretty simple to do. Of course, we're going to take the radius, which is 3/4. Okay, the radius, which is 3/4 squared, times 3.14. Now, at this point, if you'd rather use 0.75 and square that, I have no problem with that. Please do whatever you want to do. There's no preference. I left mine 3/4. So when you square 3/4, you get 9/16. Square the 3, that's 9. Excuse me. Square the 4, that's 16. And then take your pi times your radius squared, and you will get the correct answer, which is 1.77 inches squared. Okay? Pretty simple. Moving on to number 11. Alright, number 11. They want us to find the area of this outer ring right here. Now, like I've said before, guys, what I would think the easiest thing to do is to find the entire area of that whole circle, and then find the area of this little white circle right here, and subtract it out, and you're left with the area of the outer ring. Okay, so with that in mind, here we go. The entire radius from the inside all the way to the outside is 32. So if I'm going to find the area of the entire circle, it's going to be 3.14 times 32 squared. So here we go. 3.14 times 32 squared gives us 3,215.36. Now that's the area of the entire circle. Now let's find the area of this little white circle here. Your radius is 8, so 3.14 times 8 squared would be 3.14 times 64, which gives us 200.96. Now, students, if you take the area of the entire circle minus the area of the white circle, you're going to get, hold on one second, please, 3,014.4. That's really close to what they had in the book. We're off a little bit, but 3,014.4. 3,014.4 square millimeters. Alright, moving on to number 12. Now, they want us to find the area of this segment right here, segment of a circle. So you know what to do, guys. You know what to do. Find the area of the entire sector, like this. Like we've talked about, all of that. And then find the area of the triangle and subtract out that area of the triangle. And when you do, you're left over with that sector right there, or that segment right there. Remember, this part right here is called a segment of a circle, okay? And this entire area is called a sector of a circle, okay? We talked about that in your notes. So having said that, let's jump right into this. The area of the circle would be 3.14 times 12 squared. So the area of the entire circle is 452.16. Now, what fraction of the circle? Well, look, guys, anytime it's 90 degrees, it's going to be 1/4 of a circle, because 90 over 360 is 1/4. So let's remember that. Anytime it's a central angle of 60, if the central angle here is 60, it's always going to be 1/6, because 60 over 360 is 1/6. Memorize those. It'll save you time, okay? So this sector right here is 1/4 of the entire circle. So 452.16 times 1/4, or times 0.25, which would give us the area of the sector. So the area of the sector is 113.04. Now we can very quickly find the area of this triangle, because we have a right triangle right here, and the base is 12 and the height is 12, because they're both radii. They're both a radius. So the area of the triangle is 1/2 times the base times the height, which would give you 72. Alright, so the triangle equals 72.00. So let's subtract those two numbers very quickly, and we should come up with the correct answer. 41.04 is what I get. The back of the book has 41.10. So we're right there on the money, okay? And that would be square yards. I don't set a very good example of labeling your answers, but you really should label your answers, okay? Moving on to number 13. Okay, students, finally a more challenging problem. I love challenging problems. We have this this shaded area here, or region, this shaded region here, and this shaded region here. Now, first of all, I want to show you something. We know that a semicircle is 180 degrees from here all the way to here. Well, guys, look, we know this length here has to be the same as this length here. They're both a radius, okay? And so if this is 60 degrees, this has to be 60 also, and this has to be 60 also to give us a total of 180. So the first thing I want to point out to you is this sector right here is the exact same sector as this one here, and the exact same as this sector right here. So if we find the area of one, we have found the area of all three. Got it? So first of all, I'm going to find the area of this sector right here. Alright, so let's find the area of the entire circle. The radius is 2, so we have 3.14 times 2 squared. Let me grab my calculator real quick. That's going to give me 12.56. So there's the area of the entire circle. Now, this is 60 degrees. I've taught you. Whenever the central angle is 60, that's 1/6 of the entire circle. So take your total area times 1/6, and the area of one sector is 2.093. I'm going to put 2.09. So this shaded area is 2.09. This shaded area is 2.09. And now look, I know this entire area here is 2.09. All I have to do is subtract out this triangle, and I'm home free. So here's my triangle right here. Remember, whenever your central angle is 60, then we know it's a 60, 60, 60 triangle. And I know my radius is 2. So this is 2, this is 2, this is 2. Drop down your height or your altitude. So now I know this length right here is 1. This angle here is 30. This angle is 60. So I can very quickly find the height by using my shortcuts, okay? If the hypotenuse is 2, the shorter leg is 1. And you always take the shorter leg and multiply it by the square root of 3 to get the longer leg. So your height is 1 square root of 3. Now you're realizing how important it was for you to learn your shortcuts for your 45, 45, 90 triangles and your 30, 60, 90 triangles. Guys, when you get behind in math, math builds and it messes things up for the future. That's why you can't get behind in your math classes, okay? Alright, lecture over. Let's continue on. So in order to find the area of this triangle, I take the entire base, which is 2, times the height, which is 1 square root of 3 or square root of 3, times 1/2. So 1/2 times the base times the height, which would give you square root of 3, or in other words, 1.73. So the entire sector right here is 2.09. The triangle is 1.73. So if we subtract those two, we're going to get 26. Let's see here, 0.36. 0.36 for this little sliver right here. So this area is 2.09. This area here is 2.09. This area here is 0.36. Add them up, and you get 4.54. And I hope that's right. We did a lot of work on that. Yes, they have 4.55. We have 4.54 centimeters squared. So there's the area of the shaded region. Good, another difficult problem. That's good for you guys. All right, watch what I'm going to do. There might be a faster way to do this. This is how I do this. This is the easiest way to do it. I said to myself, forget the entire problem except this circle here and this circle here. Okay? So I'm going to deal with those two circles. Are you ready? Now, I want us to find the area of this outer ring. Alright? So, first of all, notice all of these little distances here are 1. All of these little distances are 1. So that means the radius from here to here is 1. And the radius from here all the way out to the end of the circle is 2. Okay? Alright. So students, when you break the inner ring down to this right here, it's really not that difficult. So students, let's find the area of the entire circle. And the radius of the entire circle is 2. So we have 3.14 times 2 squared, which would give us 12.56. Now, find the area of the little circle, which has a radius of 1. And of course, that's going to be 3.14 if you work that out. So subtract, and you're going to get 9.42. Okay, so I just found the area of this blue ring right here, 9.42. Now, all I have to do is find the area of this outer ring, add the two areas together, and I have my answer. So watch this. Okay, here's the outer circle. Then here's this circle. I'm going to forget everything else. Nothing else matters to me except those two circles, okay? So let's pull this one out. Well, that'll work. That's fine. We'll just do that. And let's see if we can pull this over here. Alright, now. Okay, look. The radius from here all the way out would be, let's see, 1, 2, 3, 4. 4 all the way out. And the radius from here to here would be 3. So let's find the area of the entire circle. Okay? And then find the area of this inner white circle and subtract the 2. So the area of the entire circle is 3.14 times radius squared. So we have 3.14 times 16 would give us 50.24. The area of the inner circle would be 3.14 times your radius squared, which would be 3 squared. So we would have 28.26. Now subtract those two, and you're going to get 21.98. So this blue ring here all the way around has an area of 21.98. Add those two together, and you're going to get 31.4. Now I hope that's the right answer. If not, I really don't want to start over. That's for sure. Let's take a look at the book here and see if that's what they have. They have 31.42, so we're good, okay? Hope that makes sense. Moving on to number 15. Okay, now look. We learned a long time ago that when two lines intersect, their vertical angles are congruent. So this angle here is congruent to this angle here. So if this is 120 degrees and this is 120 degrees, that means these two sectors are identical. So all I have to do is find the area of one sector and then multiply it by 2. Okay? So in order to find the area of a sector, you guys should know this. We first find the area of the entire circle. So 3.14 times the radius squared. 3.14 times 25 gives us 78.5. So there's the area of the entire circle. Okay? Now, 120 over 360 is going to give us 1/3. So that's 1/3 of the circle. So I'm going to take 78.5 times 1/3. And I'm going to get 26.16. I'm going to put 26.2. So this sector is 26.2. This sector is 26.2. Add those two together, and you will get 52.4 square inches. Alright, let's take a look at the answer. The answer is 52.36. Okay, so we have 52.4, close enough. Alright, number 16 now. Guys, this is really not as difficult as it looks. We're going to find this area here, and add them together. So forget about this problem up here. Just forget about that. Focus all of your attention right now on this sector here. Alright? And then you know how to find the area of the shaded region. We're going to find the area of the entire sector and then subtract out the triangle right here. So here we go. The entire area of the circle is 3.14 times radius squared. So 3.14 times 16. 50.24. So there's the area of the entire circle. Alright? Now, we're going to take that times, remember 60 is always 1/6 of the entire 60-60 triangle. So drop down your altitude. This would be 30. This would be 60. This would be a right angle. Your radii are 4. So all of the sides are 4. Okay? So it means your little side here is 2. Always take your little leg, multiply it by the square root of 3. And there's your height. So in order to find the area of this triangle, we have 1/2 times the base, well the whole base is 4, times the height is 2 square root of 3. So we get this right here, 6.93. So the triangle is 6.93. So if we subtract those two, we're going to get 1.44. So now I know this little area right here. That's called a segment of a circle, okay? That little segment of a circle right there, the area is 1.44. Alright, now let's find the area of this other shaded part right here. Well, first, we're going to have to find the area of the entire, I think I need to get that, what was that area of the whole circle, 50.24. Okay, alright, now, the area of the entire circle, before I forget it, 50.24. Let's find the area of this whole sector, okay? So it's a 90-degree sector. We know that's 1/4 of the circle. So I'm going to take the area times 0.25 or times 1/4, and I'm going to get 12.56. So the area of the entire sector equals 12.56. Alright. Now, next, I'm going to find the area of this triangle here and subtract it out. Well, guys, it's a right triangle. This is a length of 4. This is also a radius right here. It's a length of 4. So your base is 4. Your height is 4. So the area of the triangle is 1/2 times the base times the height, which is 8. So the area of the triangle equals 8.00. So we get 4.56. So the area of this little sector here is 4.56. So add these two numbers together. 4.56 times 1.4 plus 1.44 would be 0, carrier 1, 0, carrier 1. 6.00 square centimeters. I hope that's right. I'm kind of afraid to look. Yep, they have 6.02. Alright, so that is correct. Alright, moving on to number 17 through 20. Now these 19 and 20 are really challenging. 17 is pretty easy. 18 is a little more difficult. 19 and 20 are really good and challenging, okay? So here we go. 17, they say to us, the directions say to find the radius. So we're looking for the radius. Now, the circle has an area of 201 square meters. Alright, 201 square meters. So, if I want to find the radius, first of all, the area of a circle is pi r squared, okay? So, for area, I put 201. See what I'm doing? For pi, I put 3.14. And now I just solve for r squared. That's it. I mean, you're trying to solve for r, so get r by itself. So if you take 201 and divide that by 3.14, you're going to get 64.01 rounded. Got it? Now, take the square root of both sides, and you'll get approximately 8. If you take the square root of 64.01, you'll get 8. The square root of r squared is r. So r equals approximately 8. And if I label my answers like I should, 8 meters. Because your area was square meters, so your radius has to be in meters. Okay, a little more difficult now, but really not that hard, guys. Look, come back here. If I tell you the area of a circle, can you not find the radius? Well, I just did it for you. Of course you can. For the area, you put in the area. For pi, you put in 3.14, and then you solve for r. So once you know the area of a circle, is it really simple to find the radius? Yes, it is. So with that in mind, look at this. I don't know the area of a circle, but I know the area of one sector, which is 40 degrees. I know the area of this sector right here is what? 59, right? That's the area. Now hold it, guys. All that I have to do is see how many of these sectors go all the way around the circle. So I'm going to take 360 divided by 40. I get 9. So what I'm trying is if you were to continue to draw these 40-degree sectors all the way around the circle. And mine's way too big, but let's see, 90 degrees is here, so 45 is here, so 40 is about right there. One, two, three, four, five, six, 7, 8, 9. There we go. So what I'm trying to show you is if your central angle is 40, then you can get 9 of these all the way around. How do I know that? Because 40 times 9 is 360, and from here all the way to here is 360 degrees. So I'm trying to show you that if one of these areas is 59, then take 59 times what? 9. And that'll give you the area of the whole circle. 59 times 9 of these gives you the area of the whole circle. So the area of the whole circle is 531. Now that you know the area of the entire circle, we can find the radius. We did it back here. The area of the circle is 201, and we found the radius. So the area of the circle is 531. So area equals pi r squared. Take 531 and divide that by 3.14, and you're going to get 169.11. 169.11 equals r squared. Take the square root of both sides and you will get approximately 13. So the radius is 13. Now we get to the harder ones, okay? Alright, first of all, they tell us to solve for r, and they're telling us the inner ring is the r. So I'm going to go ahead and draw a circle, or kind of a circle with my drawing skills, and there, another circle. Now, the inner ring is your r, so that's what you're trying to solve for. Got it? Let that sink in. Inner radius r. That's what you're trying to solve for. So can I make this as basic as possible, guys? If you can just find the area of this inner circle, then you're home free, right? Let's pretend that I told you the area of this inner circle is 50. Well, then you know what to do. You would say area equals pi r squared. For area, you would put 50. For pi, you'd put 3.14. And for radius, you would put r. And then you can find the radius, right? So really what we have to do is somehow find the area of this inner circle. Once we find the area of this inner circle, we can find the radius. Now, they really don't explain this very well. I'm going to try to help you, okay? When it says outer radius is 6, that means from here to here is 6, okay? Now, when they say the area is 62.83, guys, they're, believe it or not, they're talking about this ring right here. They really should have labeled that better. Trust me, I've worked this out. I've got the right answer. And if I'm wrong, I can't think of any other way that they meant this, okay? So they're telling you the outer ring area is 62.83. Now, guys, let's think about this. Come on. If I find the area of this entire circle, got it? This entire circle, just like this. And then subtract out the outer ring like this. Look carefully. What area am I left over with? This inner circle. And at the very beginning of the problem, I told you that's our goal. If we can find the area of this inner circle, then we can find the radius. So, Mr. Earhart, how are we going to find the area of that black ring? They give it to us, guys, right here. They give it to us right here. Okay, so this outer ring has an area of 62.83. So let's find the area of the entire circle real quick, okay? I would do that by pi times radius squared. And the whole big circle's radius is 6. So 3.14 times 36 gives me 113.04. Now subtract out the outer ring. And we're going to get, I believe this, I did it quickly in my head, yes, 50.21. So I found the area of the entire circle. Then I subtracted out the ring. And I'm left with this. That means this inner small circle right here has an area of 50.21. So now I'm ready to solve for r. Remember, area equals pi r squared. So the area of the small inner circle is 50.21 equals 3.14. Then radius squared. So I'm going to take 50.21 and divide that by 3.14, and I'll get 15.99. Now take the square root of both sides. Now we'll get approximately 4. So the answer hopefully is 4. Yes. Okay. Why don't you try 20 on? I'm going to go ahead and work out 20, but maybe pause the video and try it on your own. It's identical to the last problem. Identical. Okay. Here we go. Here's my big circle. Here's my smaller inner circle. And the inner radius is once again what I'm looking for. It's my r. The outer radius from tip to tip here is 3.6 is my entire radius here. Okay, 3.6. Alright, now they tell me the area of the outer ring is 32.67. That's the area of this outer ring. Okay, so the first thing I'm going to do is I'm going to find the area of this entire big circle. Okay, that's the first thing I'm going to do. So that would be, let's see, area equals pi times r squared. So 3.6 squared. So 3.14 times 3.6 squared gives me 40.6944. So there's the entire circle, 40.6944. Now, if I subtract out, I just found the area of this entire circle. If I subtract out this ring right here, like I showed you in the last problem, if I subtract out this ring, then what I'm left over with is just this area of the circle on the inside. Alright, so I'm going to go ahead and do that this time. I'm going to subtract out this outer ring, which is 32.67. And let's see what we get. 0.0244. And this would be 8. Alright, so there I just found the area of this inner circle right here. Okay, so this circle right here has an area of 8.0244. And what I'm trying to solve for now is the radius. So area equals pi r squared. Area is 8.0244 equals 3.14 times radius squared. So 8.0244 divided by 3.14 gives me 2.56 if I round it. And then take the square root of that. And I'm going to get 1.59. 1.59 is the radius, okay, which is hopefully correct. 1.60, so close enough. Alright, moving on to 21, 22, 23, and 24. Now students, numbers 21 through 24 look challenging, and they are, but they're not that challenging. 24 is pretty challenging, but really, to be honest with you, these are not as challenging as they look. Watch this. They want you to find the area of this shaded in part, and you're probably thinking, how in the world can I do that? Guys, it's so easy. All of these 4 circles are the same. So all that you have to do is find the area of this entire square, right? Find the area of this entire square. Now watch this. And then subtract out the 4 circles. So if you subtract out that circle there, you get the point. Subtract out that circle there. Subtract out that circle there. And subtract out that circle there. Then you're left over with the shaded part. That's really not that bad, guys, because look, let's find the area of the square. Well, that's hard to do. I'm just joking with you. Oh my goodness. 12 times 12. So the area of the square is 144. Now let's find the area of one of these circles. Okay, if this whole line is 12, what's half of this line from here to here? 6. So what's the radius of this circle? 3. There you go. Find the area of that circle. Pi r squared. It's a calculator guys. 3.14 times 9, 28.26. So one circle is 28.26. Well, I've got 4 of those. So take 28.26 times 4, and all of those white circles together are 113.04. So the entire area is 144. The area of all 4 white circles is this. Subtract the 2, and you're done. So 30.96. 30.96. Okay, there you go. Square meters. Square meters. All right, number 22. That's a little more difficult, but again, guys, look. If you just find the area of one segment right here, there's 6 of them. 1, 2, 3, 4, 5, 6. Just find the area of one of these, and then you have the area of all 6 of them. Multiply it by 6. Okay. So all we have to do is find the area of just one of these sectors here. So I'm gonna go ahead and section this off. Let's find the area of this entire sector. Now, first of all, I gotta find this angle. Now, if I were to draw triangles throughout this entire regular polygon, how many triangles would I have? 1, 2, 3, 4, 5, 6. Okay, so I've got 6 triangles. Now, if I start here and go all the way to here, it's 360, right? So each one of these angles then has to be 60, because 60 times 6 is 360, and there's 6 of these triangles. Got it? So now I know the central angle has to be 60. So here we go. My area of the entire circle is 3.14 times 5 squared. Okay, so 3.14 times 25 is 78.5. So there's the area of the entire circle. Now, this sector is 1/6 of the entire circle. So 78.5 times 1/6 would give me 13.08. So the sector equals 13.08. Now, remember, to find the area of this little sliver right here, that segment, we find the area of the entire sector, which we did, and then we find the area of the triangle and subtract the 2. So here's your triangle right here. Remember, it's a 60, 60, 60 triangle. This is 5, this is 5, this is 5. Drop your altitude down. So now this segment here is 2.5. Remember, this is 30, this is 60. When you have a 30, 60, 90 triangle, this longer leg is always the shorter leg, which is 2.5 times the square root of 3. So there's your height, 2.5 times the square root of 3. What's your base? 5. The entire base of the triangle is 5. Remember, you're not finding the area of this triangle here. You're finding the area of this entire triangle, okay? So the base is 5, and the height is 2.5 square root of 3. So the area of the triangle is 1/2 times the base times the height, which is 2.5 square root of 3. Alright, so here we go. 5 times 2.5 square root of 3 times 1/2. I'm getting 10.82. I hope that's correct. 10.82. That's the area of the triangle. So subtract those 2, and you will get 2.26. 2.26. So this little sector right here, this little segment right here, is 2.26. There are how many of those? 6. So 2.26 times 6 would be 13.56. 13.59, close enough. Square inches. Square inches. Alright, number 23. Okay, it looks difficult, but it's not. First of all, if I can find the area of this entire semicircle, like this, and then subtract out each one of these little semicircles here, then I'm left over with the shaded part. So let's first find the area of this entire semicircle, okay? Now let's not forget it's pi r squared, okay? To find the area of a circle. So the area of this, if I had an entire circle like this, my radius would be 24. From here to here, 24. Okay, right? Half of 48, 24. So my radius would be 24, so 3.14 that's the area for an entire circle, pi r squared. We got to divide that in half. So, I'm sorry, it's 0.641. 1808.64. Divide that by 2 and you'll get 904.32. So the area of the semicircle is 904.32. Now, look guys, from here to here would be 24, excuse me, right? So then cut that in half. From here to here would be 12. So here's your little circle right here. The diameter is 12, is it not? Sure it is. Cut that in half, and the radius of one of these little circles would be 6. So, find the area of this entire circle, and then cut it in half. How do you find the area of this entire circle? Well, it's going to be, let's see, 1 half, pi r squared. So 3.14 times 36 gives me 113.04. Now divide that by 2 because you only want the area of half a circle. So divide that by 2. And you're going to get 56.52. So one of these little circles right here is 56.52. Now there's 4 of those, correct? Sure. So take 56.52 times 4, and you're going to get 226.08. So the area of this entire half a circle is 904.32. The area of all these little white circles combined is 226. Subtract out the white circles, and you'll have the area of the shaded part. So this would be 24, and this would be that, I believe, 678.24, 678.58, close enough, definitely close enough, okay? So there we go, centimeters squared. All right, moving on to number 24. All right, now, out of the last 4 problems we just did, 21 through 24, this is definitely the hardest one, I will admit that, okay? But we can still do this. Now, first of all, I'd like to challenge you to simply find the area of one of these circles right here. And then multiply it by 4 because there's 4 of those, okay? That's the first thing we can do. Because if you look in your book, these 4 circles are shaded, and then this is shaded up here, and this is shaded up here. Don't worry about this part here, or this part here until later. Right now, we're worrying about these 4 circles right here. So, here we go. From here all the way across is 4. Cut that in half. From here to here is 2. Cut that in half. From here to here is 1. So cut that in half. The radius from there to there is 1/2. So the radius of one of these circles is 1/2. Did you see that okay? Go all the way across. You have 4. Cut that in half, and this would be 2. Cut that in half, and this would be 1. Cut that in half, and this would be 1/2. So my radius is 1/2. So pi r squared, right? 3.14 times 1/2 squared. 0.785. So one of these circles is 0.785 times 4, okay, which is 3.14. So I'm doing pretty good, so I'm just going to leave it for right now. I'm going to go ahead and do this. I think I'm going to confuse you if I start doing all that. I'm just going to simply do this. 0.785, 0.785, 0.785, 0.785. There. Now, how can I find the area of these weird shapes up here and down here? Well, let's see. Let's find out, okay? First of all, I'm going to take my handy D&D Mimeopad pen that's actually worked very well for this video for once in its life. And now I'm going to copy this circle here. And I'm going to copy this circle here, okay? Now watch how I eliminate all the confusion. Alright, I'm going to grab this red circle here, pull it over here, grab this red circle. Well, try to grab that red circle. Pull it right here. Grab this red circle and pull it right here. They're supposed to barely touch. Alright, good enough. Close enough. Now, students, please take a look at this. Do you not see what to do? Guys, if I find find the area of this entire circle, and then subtract out area number 1, this white, the small circle, and area number 2, the small circle. I'm left with this area here and this area here. So, not too bad, okay? Let's find the area of the entire circle. If the whole diameter going across is 4, cut that in half, then the radius from here to here is 2. So the radius of the big circle is 2. So pi times r squared. Pi times 2 squared, 3.14, times 4 is 12.56. So the area of that entire big circle is 12.56. Got it? Now, what's the area of one of these little circles here? Well, let's find the radius. We know from here to here it has to be 2, because all the way across is 4. Okay? So from here to here is 2. So if from here to here is 2, divide that in half, and this would be 1. So I have 3.14 times 1 squared. Well, guys, 1 squared is 1. 1 times 1 is 1. 1 times 3.14 is 3.14. So this circle has an area of 3.14. This circle has an area of 3.14. Add those together and you get 6.28. So the entire area of this whole big circle is 12.56. The total area of these two smaller circles here is 6.28. Subtract those two out, okay? Subtract out 12.56 minus 6.28, and you're going to get 6.28. So this area here plus this area here is 6.28, then plus 0.785 times 4, there's 4 of those, which gives me 3.14. So add those together and we get 9.62. 9.62. You might have to back that up and watch it again to make sure that we got it right. Actually, 9.42. I got that one exactly right. 9.42, which is exactly right. So students, back this up and watch again if you need to, okay? These have been really, really good thinking problems for you guys. Hopefully this video has been a help to you. If you have any questions, don't hesitate to call